Now?
Yes, doctor.
Yes, very good. So welcome to the, I think this is the fourth level of our MATLAB workshop, and it's related to MATLAB App Designer. App Designer is a toolbox on MATLAB, or خلينا نحكي it's a toolbox, yes, on MATLAB, and it helps you to make a graphical user interface for the user. So he can, for example, enter a certain data or select a certain data. نخلي الاب ديزاينر على جنب الآن and let's discuss our task for today. I prepared for you one example to guide you through the app designer. It's a comprehensive example. So all of you are familiar with the fluid flow inside a pipe or a circular tube. Okay, so what we are going to do today, MATLAB App Designer. Okay, we will design a certain app to calculate the pressure loss inside a certain pipe as follows. شوفوا الفيزيكس تبع البروبلم. It will be something like this. This is our pipe. Okay. This is the length of the pipe L. This is the diameter of the pipe. Okay. Now inside the pipe we have a certain material. So we have a certain material flowing inside the pipe. So this is the material. أو fluid material خلينا نحكي. And this is the pipe material. Okay. طيب. Now for this pipe, الدي والال والفلويد ماتيريال والبايب ماتيريال are user input. So الدايمتر، اللينث، الفلويد ماتيريال، البايب ماتيريال. على فكرة ال Q as well, which is the flow rate. These are user input. The user will be asked to input these variables in a certain form. Okay, بشكل معين. So he can enter the variables as number, he can enter them as whatever you like. So we will add them as a slider or selection, whatever. I will show you how to do it now. Now what we need to, or our results, we need the following. أول إشي to calculate Reynolds number, and we know that Reynolds equals to rho VD divided by mu, where D is the diameter, V is the velocity, rho is the density of the fluid, and mu is the dynamic viscosity of the fluid. اثنين, we need the software to tell us if the flow is laminar or turbulent. So the software should give us a result if the flow is laminar or turbulent. 3. We need the software to calculate the friction factor. And you know that the friction factor depends on the flow, if it is laminar or turbulent. 4. We need the software to calculate the pressure loss across the pipe. Okay. Type. Once we finish, we need also table for data collection and we need also a graph between velocity, a graph for delta P versus V. Okay, and this is what is required, and you can do any graph you like or you can collect any data you like. However, this is what we need in our program. واضح؟ الآن الفيزيكس تبعت البروبلم هاي موجودة هون، ولكن شو بدي كمان أنا أسوي؟ I need to give 3 selections for the fluid material. So 3 selections. And I need to give also 3 selections for the pipe material. Okay, so what I'm going to do is to program 3 materials for the fluid, and as you know, Reynolds number, as you can see, depends on the density of the fluid and the dynamic viscosity. So I need to define as well the density and the dynamic viscosity for each one of these materials. واضح؟ And for the pipe material also, I need to define for the pipe material what makes a certain pipe material different than other pipe. It is the epsilon, اللي هو something called roughness of the pipe or internal roughness of the pipe, and that's it. It is the roughness of the pipe from inside. Okay. طيب خلينا نشوف. خلاص physics are واضحة. Is it clear? The problem is clear. Okay. طيب, can you give me just 2 minutes? There is a problem with my account. I need to call the IT. 1 minute. Okay, so it's working now. This is the MATLAB screen. I just opened the MATLAB from the store. Can you see my screen?
Yes.
Okay, very good. So in order to start the app designer, we just type app designer. Okay, app designer and enter. Okay, so this is the app designer. This is called the design view, and this is called the code view. Okay, this is where you put your fields, for example, button, axis, whatever from this menu. And this is where you write the code for each one of these components. واضح? And before we start, I will show you the program that we are going to do today, inshallah. I made it yesterday. And let me, before I start with the programming, let me show you how does it work. And we need to go for MATLAB. Okay, so this is our program. Let me press on run and show you how does it work. So you will have an idea about our task today. Okay. So can you see my screen now? The app, can you see the app screen now?
Yes.
Okay. So I can select, I have 3 options for the pipe material. I can select between cast iron, steel, or brass. I also have three options for the fluid material: water, oil, kerosene. Okay. The pipe length is a user input in meter, so you can select any pipe length, for example, 20 meter, 40 meter. You can also select the pipe diameter. You can say, for example, it is 20 millimeter, and you can select the flow rate in liter per minute. Okay. So then we can start or press on calculate. It will calculate Reynolds number. It will give you the flow type if it is laminar or turbulent. It will calculate the velocity in meter per second. It will calculate the friction factor. Then it will give you the pressure loss in kilopascal. الكالكوليشن screen واضحة؟
Yes.
Okay. Now you can, for example, collect a certain data set. You will collect the velocity and the pressure loss. Okay. Now let's go for another flow rate. You will have different values here. You can also collect the data, and you can go and increase the flow rate. You can collect the data as well. Then you can plot the pressure loss with the velocity. Okay, so this is our task for today. واضح? Now what I did, I prepared for you the pipe material property roughness, the values, and we have the value. Let's assume you should have the values for the pipe material roughness, and you should have the values for the fluid material or the properties like density and viscosity for the fluid materials. Now let's assume we have them. I have the values. Okay. Now for the equations, I will show the equations when we go through the programming. واضح? So let me close this. Okay, and start a new page or a new project. Okay, can you see the new project now?
Yes.
Okay, very good. So first of all, this library contains the components for your program. So let me start by taking the list box. This is called a list box. By default, it has 4 items. Okay, so you can increase or add more items or take out one of these items. Okay, so this is the list for the pipe material. Okay, now usually we start by the design, and we design the graphical user interface, then we will start by the programming. Okay, so I need the user to select from these 3 materials. So let me call this the list box name. I will call it material, or I will call it select material or pipe material, whatever you like. Okay. Now I have the items here. You select, you will see the items on the component browser here. Okay. So I have item 1, item 2, item 3, item 4. I just need 3 items. So I will remove this. Okay. Item 1, maybe it is cast iron. Okay. What are the materials we are using? Let me check. Cast iron, steel and brass. So the first one will be cast iron. The second one, depending on your situation or depending on your requirements, and the third one is brass. خلاص. And if you select here, you will see that the name, this is the name of your list box. It's called app.pipematerial list box. Okay, its name is app.pipematerial list box. This is very important because you will use it in the programming. So if you need to recall this list, you just use this name for the list. Right. Now we will do another one, and this will be called a fluid material. So it is called fluid material. So we will have three materials. If you click here, you will see the items of the list box here. We need the three only. The first one will be water. The second one will be oil. It is engine oil, but I will write it as oil for simplicity so we don't have large name. And we will have kerosene as well. Okay, if you need to check the name of this list box, it's called app.fluidMaterial list box. واضح? Okay. So far, any problem? We are just designing the interface of the program. Now we need to for example, prepare the slider or the input location for the pipe length. Usually I like the slider because the slider gives you a period or gives you a maximum and minimum values for your value, for example. So if I need to define the pipe material, pipe length, sorry, pipe length in meter, I can make it like this, and or I can make it like this, for example. Okay. The difference between this one and this one is that the user here is bounded between 0 and 100, so he cannot add any values other than these values contained between 0 and 100. However, here the user can input any value he like. Okay, so it's better, if you have a certain application, I find it actually better to give a certain maximum and minimum values so you will not get values outside your range. Okay, the other option is to make this and make the edit field, make only an edit field here. So he can select the pipe length and it will be written here. Okay. So I will keep using the slider. Now the slider has certain options. You can press on the slider here and you can check the properties of the slider. Its label or its name is pipe length in meter. Now it has values. Now its value is 0 because it's the slider is at 0. You can select a minimum and a maximum value. Okay, so let's make the minimum to be 10 meters. So you can see now that the digits, it changed automatically. However, you can make them also manually. So you can change these tick marks depending on your situation. Okay, so let's leave this as it is. And let's have another one for the pipe diameter. So let me bring the slider for pipe diameter. I'm just preparing the interface. So this will be pipe diameter in millimeters. Okay. You can change the location of your slider or the location of your field, whatever you find appropriate. Okay, so I'll put this one here. Tamam. Now let me make this from also the minimum value. Let me make it as 10 millimeters and the maximum to be like 50 millimeters. طبعا it depends on your application as well. Okay. طيب, let me now add a slider, another slider for flow rate. So this will be flow rate in liter per minute. Liter per minute. Okay. يعني the flow rate in liter per minute can be, for example, a range from 0 to 30. And it also depends on your application. Type. So now we are done with the input variables. Let's go and check the output variables. Okay, we are done with the input variables. Let's make the output variables. First of all, I need to calculate Reynolds number. So Reynolds number is a number, correct? So I get, or I bring the edit field numeric for numbers. So I can bring this here, and here I can write Reynolds number, for example. Okay, now you can also have properties for this edit field. I can remove this 0, for example. I will leave it, but let me make it at the center. So once the number is sent to this field, it will be at the center of the field or at the center of this box. واضح؟ طيب. Now I need to define the flow, if it is laminar or turbulent. So the software or the program needs to give you a string or a text in a certain field to tell you that it is laminar or turbulent. So we need to bring the edit field text. Edit field text. It's called edit field text. Note that this is a number and this is a text. Okay. So I will call this flow type. Okay. See, there is no 0 here, no number here, because you have to provide a text here, correct? Type. Let me add another numeric field to calculate the velocity. So this will be the velocity in meter per second. Okay. I also need a friction factor. So this will be the friction factor. I can take it here, so all of them will be justified together. I also need another one for the pressure loss. So this is pressure loss in kilopascal. Okay, and this will be at the middle. Tamam. So now let's start with the programming here, and we will go, once we finish the programming and all the data variables, we will go and check how to do the graph and the table. Okay, so let me add a button here for calculation. So I will add a button here and I will call it calculate. Tamam. All the programming will be under the calculate button. Okay, all the programming will be under the calculate button. Now, sometimes, some people make for example, the programming of the pipe material, they can add a property here, and it will be like general property, and start programming here, and it will be transferred to the calculate button will take some data from these. However, I like this way. It is much simpler or much easier than making the calculation in each location alone. Okay. Now, so far, do you have any problem with the interface? Do you have any suggestion before we start the coding? Now, I can't see your chat box, so if there is anybody from...
No, doctor.
خلاص, can we start the coding? Okay, very good.
Yes.
Very good. So let me start the coding. I can go to the code view, and as you see, every component or every field I added is included in the coding field. okay, or in the code view. However, I don't know where to start. I don't know where is the push button. I need to search for it, okay, and maybe it does not exist yet. So I can go back to the design field and press on the calculate button, right click and go to callbacks and add function or add button pushed function callback. So this is the location for the calculate button programming. So this is the callback. Once you press calculate, it will go to this location and start doing the code or start reading the code, let's say. Okay. طيب. الآن list box, I will start with defining the list box. Okay, I will start with app material list box. Okay, before that I need to go to the app material list box. It's here now. Okay, I went here. Now I will see the callbacks for the app material list box. It gives me that the value equals to app.pipe material list box dot value. I need to change this to, I will call it material. So I will call this MAT. Okay, you can call it whatever you like. Now I can also go to the other list box, which is the fluid material list box. Okay, callbacks, and I can call this, by default it is value. I will call it fluid. Okay, now it means that fluid, the value or the variable equals to app.fluid material list box, the name, dot value means that you are taking the value from this material, from these selections. Okay, so the value can be, for example, 1, 2, or 3, because you have 3 options. However, we will not define it in this form. We will define it as a string. So we need the MATLAB or the app designer to go and check or compare the string we have with the string that he already has. Okay, so let's go back to the calculate and see the callbacks. Let me define this again here. So I will copy here. Now I will start defining the selections. So first of all, I can write an if loop, if strcmp. Now, if strcmp means string comparison. String comparison. So MATLAB will compare your string with the string in the list box. This is what I need to do. If a string comparison for the variable mat with my variable, which is خليني اشوف الفاريبلز اللي دخلتهم انا عندي هون. اول واحد كان ستيل صح او كاست ايرون. سو كاست ايرون. Okay. Then this means that I will define epsilon as E. Okay, this means that E equals to, let me check what is the value of E I provided here. .26. خليني اكتبهم عندي على ورقة معلش تحملوني. E 0.26, steel 0.002, and الثالث اللي هو 0.0015. Okay, so I will define this in the same manner. So E equals to 0.26. Now, for the second material, it will be 0.002. So I will write else f strcmp for mat with steel. Okay. E will be 0.002. Now, before I go further, if you read this, F strength comparison between the value of mat, this is mat. See, this is the value of the mat material. If it was named value, you will write value here. Okay. And cast iron. Now I gave him the value of cast iron as a string. This is string, and once you need to compare a string, the string should be in these quotations. Okay. Now what happens here? MATLAB will go and check your selection and compare it to this selection or compare it to this string. If they are the same, your E will be 0.26. If they are not the same, for example, if it is a steel, it will check or compare this string with the string in the list box. If they are the same, it will give you a value of E to be 0.002. Okay. Now, since I have three options only, you cannot have, or you cannot, if you have three options, I have a list box of three options. Now, this means that you have three probabilities, only cast iron, steel, or brass, or let's say in other words, either it is cast iron, steel, or whatever. This is why we add else instead of else f. Okay, E equals to 0.0015, then end. Why did we use else? You can also use else f. You can write else f strcmp mat brass E equals to 0.0015. However, it is easier to do it like this because we only have three options, and the third option will be brass. Okay, so if someone used this list box, he can only select steel, cast iron, or brass. If he did not select cast iron and did not select steel, he should select brass. Okay, this is why we used else instead of else f. You can also use else f. Now let me define the list box of the fluid material. I can bring this here. And we do the same. F strcmp for fluid. What fluids we have? Water. The first one is water. Now we need to provide the values of rho equals to and mu equals to something. Now else f, I will copy this to make it faster, and this will be oil. Okay, rho equals to and mu equals to else rho equals to and mu equals to. Rho is the density and mu is the viscosity. Okay. Let me again go and take the values from here. The values are as well as follows: 870. Sorry, this should be 998. So 998 0.0175 950 0.0175 this should be high 1 e to the power minus 3 أو خليها مثلا 0.001. This is for water. For oil it will be 950 0.091 810 0.00164. So let me write the properties now. So this one will be density of water. طبعا we are working on 20 degrees, so our temperature is 20 degrees Celsius. This will be 0.001. Now for oil, this will be 950, and this will be 0.091. And for the third one, which is kerosene, this will be 810, and this will be 0.00164. Now, end. خلاص. Now we define the list box. إلى الآن, so far, do you have any problems? So let's go and define the pipe length. See, the pipe length slider is here. If you press at the pipe length slider, you will have its name. Its name is app.pipelength_m_slider. Okay, so the pipe length is called L. Usually, the notation for pipe length equals to L. So L equals to the value that is taken from the slider. Correct? So I can write L equals to app dot. Then you can go to the slider here and double click and copy its name. Okay? Then you put value. So this means that the value of L will take the value from the slider. Whatever the user inputs or select a value, this value will be stored in the variable called L. Okay? The same for D. So I can say that D is also equals to, this is the pipe diameter slider. So I can write or take this as copy, Control C, D equals to app dot name, whatever the name is, okay? Whatever the name is, you can write it. Okay? Now Q is the flow rate. Q equals to, we go here, the flow rate in liter per minute. So this is the flow rate LPM slider. It's called flow rate LPM slider. So I can copy this and define it as app dot value. So now I have just defined L, D, and Q. Okay. Now for Q, it is in liter per minute. So let me change it into cubic meter per second. So I can write Q equals to Q divided by liter per minute. Liter is 10 to the power minus 3 cubic meter. And minute is 60 seconds. So in order to convert liter per minute into a cubic meter per second, you have to divide by 60,000. Correct? So we have a Q now in cubic meter per second. واضح? Any question? Okay, very good. So now let me start with the velocity. Now velocity, based on the continuity equation, equals to okay, so I will give for A. Yes. Any question? I can see. I can hear something.
Yes. ask إنه ما غيرت البايب لينك دي والكيو من الكول باك. ما غيرت شو اسمهم value.
Yes.
So انت بالاول سويت call back function وغيرت اسمهم، ليش هالمره ما سويت نفس الشيء؟
وين بأي واحد؟ هاد ولا
original name؟ لا مش wait let me just check mine. مش بالبوتون بالاوريجينال فانكشن تبع كل واحد فيهم.
اوكي.
يعني مش يو دبل كليكت على البايب ماتيريال وسويت كول باك غيرت اسمها لمات، بعدين يو دبل كليكت على الفلويد ماتيريال وغيرت اسمها لفلويد، فليش ما سويت نفس الشيء للسلايدرز؟
هلا
بما انهم معرفين فاليو.
صبر شوي خليكي. هلا هذا هو اسم الفيلد نفسه، اسم الكومبوننت، وهذا الاسم اللي انا بعطيه، بامكاني اعطي اي اسم بدي اياه. اوكي، لان فلويد، كلمه فلويد هون is the same as L, D and Q here. اوكي، this depends on your given name. يعني if you go back to the design view and for example call it, instead of pipe length, call it tube length, you have to use the tube length. It will have a different name called the tube length M, for example. You have to use this name. Okay, وضحت الآن؟ هاي ليش غيرتها لمات، وهاي ليش غيرتها لفلويد؟ See, if I only have one list box, I will leave it as it is. Okay, so if I only have one list box, I can leave it as it is. However, كلمة value نفسها، يعني هون it was written as value. كلمة value نفسها is repeated many times, so it's better to change it in order not to have any problem. So you will have two, for example, you may have more than one component and it's called value. So you have to give a unique name for each one of these values. واضح؟
I mean انت الان عرفت L انها تكون app دوت البايب ماتيريال البايب length، وبعدين لو سويت call back function راح نشوف value انها تساوي نفس القيمة، يعني معرفة باسمين كأنها. انا هيك اللي فهمته.
اي وحده معرفه باسمين.
فيك تسوي دبل رايت كليك على البايب لينك تسوي call back function
هون
yes.
اوكي،
call back function مثل ما كنت تسوي
call back add change function value.
ايوه هون اسمها value.
yes now you can change it here. هلا التغيير هون ما بيأثر على البوتون، احنا ربطنا كل شيء بالبوش بوتون. انا غيرتها هون، اوكي، لما غيرتها هون التغيير هذا ما راح يأثر، يعني ما راح يأثر على الشغل تبعي. this value since، شوفي since طلع يا هدى
yes
عندك فانكشن وعندك التكست او الكود هون، بعدين عندك انت، خلص هاي لها علاقه بالفانكشن هذا نفسه. اوكي، if you need to make it public now it is private. اوكي، هذا بنسميه private. if you need to make it public you have to go to properties here and select public property. it will make a public property. الان انا لما غيرتها هون في البدايه غيرتها بس للتوضيح فقط لا غير، ولكن لانه انا حاطط كل شيء او كل البروجرامينج عندي تحت الكالكوليت بutton، ما بدي افوت في، يعني حسيت انه موضوع الببليك بروبرتي والبرايفت بروبرتي راح يخربطكم.
يس
فربطت كل شيء.
وصلت الفكرة. لا خلاص وصلت تمام.
يس، عشان هيك هاي ما إلها معنى اصلا، هاي ما إلها معنى. you can make it value again، فما إلها معنى، بس عشان يعني اوضح لكم انه كل فانكشن له كول باك. انا رابط كل شيء تحت الكالكوليت بutton، مش as public and private properties. اوكي طيب، so now we have a queue. let me define the area of the pipe as pi over 4 pi multiplied by d square على 4. ولكن بشرط شو اسوي؟ اجي هون واحكي انه d equals to d divided by 1000. انا الان اليونت كونفرجن I always like to do it in a new, let's say, line. So the equation will not be complicated. So this means that I get the value of D as millimeter. So in the second line, I defined it as meter. واضح? The same with Q. A Q, you get it in liter per minute, then you define it as a cubic meter per second. Now, since I already defined a D here in millimeter, so you can get the area in millimeter as well. واضح? Then I can say that V equals to Q divided by A. خلاص. Q is in the appropriate unit and A is in the corresponding unit as well. واضح؟ طيب. Now let me define Reynolds. So I can say that RE equals to rho multiplied by V multiplied by D divided by mu. So you will calculate Reynolds from this value here. طيب الآن so far حسبنا الفيلوسيتي وحسبنا رينولدز. قبل ما نكمل خلينا نخزن. Let's store the values of velocity and Reynolds in the appropriate field. Okay, before we go further, but let's make a test. Okay, so I will go to Reynolds number here. Okay, this is the field. I will copy this. Okay, and write app dot control V dot value equals to RE. The same with the velocity. This is the velocity edit field. High flow type. Let's skip the flow type for now and go for the velocity edit field and type app dot value equals to SV. Okay, خلاص. If you run now, you should be able to get the values of Reynolds and the velocity. Let's try it. Okay, let's try it. So we may have some errors. This is common. I will store it in the MATLAB workshop. So I call it PF1. Okay, so let's see what happens now. If you select a certain pipe length, pipe diameter, and flow rate, and press, you select the material, whatever material, and press on calculate. Okay, so you have a value for Reynolds number, and you have a value for the velocity. These are still not programmed. Let's select another material. So you change only the fluid material. So this is not. If you change, for example, the pipe diameter, you will have other values. Correct? So far we are doing good. تمام? I will close this and go back to the code. الآن. As you know, the friction factor depends on Reynolds. If the flow is laminar, there is a certain equation for the friction factor. If the flow is turbulent, there is another equation for the friction factor, correct? So let me now give him an if loop. If Reynolds is less than 2000, friction factor F, I will call it F, equals to, who remembers the equation? F equals to 64 over Reynolds. Okay. Now, for simplicity, I will not go through the transition period. I will not go through the transition period and say I have three options. Either it is laminar, transition, or turbulent. The reason for this is that the F equation for the transition period cannot be simplified. It is complex. and I'm trying to use simple relations. And I'm trying to avoid relation. And when I define the Reynolds number to be turbulent, I will not use the friction factor equation that has plenty of iterations or something. I will just make it as a simple equation. What is the other option? Else, F equals to, I will use the equation that was used to generate the Moody chart. If you remember Moody chart, at a certain location, it only, or the friction factor only depends on the pipe material. Okay, it does not depend on the Reynolds number anymore. So if you open the Reynolds number, or sorry, if you open the Moody chart, you see after a certain Reynolds number, all the lines will be parallel to each other, which means that at the same Reynolds, you will have the same lines parallel to each other. And the same Reynolds, after a certain location, all the values depend on epsilon over d, or depends on the relative roughness. Okay, so I define this equation as, I use this equation for the definition. This is my equation. F equals to 1.14 plus 2 log d over E, where d is the diameter and E is the roughness, to the power minus 2. Okay, now you can use any equation you like. If it is correct, you can use the Colbert-White equation, but you have to make a little iterations, or you have to make another for loop inside the if loop. Okay, now in order to avoid this, I will use this simple equation. Now I need to add one more thing. I need to go for the edit field here, Reynolds number, this edit field. Okay, double click and copy its name, and I will say that app dot the name dot value equals to, now this is a string edit field, so it should be in the form of string. Okay, while here I will copy this and put it here and write, it will be other. So now, if we go back to the design view, or if you run, you should be able to also get some values for the friction factor and for the edit field, our string edit field that defines the flow type. So let's run. Can you see it now? Can you see the program? So I will select any one of these. I will select pipe length, pipe diameter, liter per minute, and I will calculate. It seems there is a problem here. Turbulent. Okay. App Reynolds number edit field dot value equals to turbulent. خلينا نشوف what is the problem here. What is the problem here? App. Let me do it again and see if it is working for laminar. So I will select oil with large pipe diameter. Okay, so it seems there a problem here with the edit field for the text. So let me check it here and see what. Let me remove this first. Maybe I have a problem with the high Control X or high Control C. Then Control X. I will run it now and see if I get a correct value for Renault's number. If I don't get a correct value for Renault's number, the problem may be with the Renault's number itself. So let me check what happens here. Okay, so I have Renault's number. Okay, so yes, I just knew what is the problem. I have to use this flow rate this one, flow type. Yes, we have a problem. We instead of using the correct, we did not use the correct callback for this box. So I have to copy this. Okay. So app dot value equals to laminar, and here I have to use the same. Okay, so now it should work correctly. So if you select any value from these, okay, so the flow now is larger than 4,000, it should be turbulent. Okay, so now I still need to put the friction factor and the pressure loss. Okay, so far any problem? في حد عم بيشتغل معاي? Anybody is doing the same task at the same time with me?
Yes, sir.
Very good. شغال معكم كويس؟
All good.
Okay, so now let me define the friction factor edit field. I will copy this and write app dot friction factor edit field dot value equals to F, and I will add, what else we have? Yes, pressure loss. Okay. So now let's define the pressure loss. The first thing is to define the head loss. Head loss equals to, as you know, in major losses, head loss equals to FL over D V square over 2G. So head loss equals to F multiplied by L, FL over D, FL. Okay, so FL over D, V square, so V square, FL, okay, divided by 2 ضرب G multiplied by D. So let me again, FL V square divided by 2 GD, correct. So this is the head loss. We have the value of F, we have the value of LN meters, we have the value of VN meter per second, okay, and we have the value of DN, meter, correct? Yes. So now we can define delta P dP as HL, okay, multiplied by rho G. صحيح? So rho multiplied by G. However, we need to convert it into, this will be in Pascal. So let me divide it by 1000 to be in kilopascal. Then I will write the callback for this edit field. App dot value equals to dp. So let me run now and see what happens. Okay, so I can select any one of these. Let me check the kerosene. Very good. Let me check oil, for example. It's working correctly. Let me select brass. It's working. Steel. It's working. Okay, water. It's working. Yes, all options are working. Very good. Okay, I will close this. I need 2 minutes only. Okay, I will come back. Assalamu alaikum. Type. So far, do you have any questions? Do you have any problems? Do you have any input? Guys, Shabab, are you there? Can you hear me?
Yes, دكتور.
Okay, واضحة الأمور للجميع؟
Yes, sir.
Okay, very good. So now let's try to add, let's go back to the design view. Okay, let me increase the size a little bit. Okay. So let me just add them together, make a new design so we can accommodate for the graph and table. So this is Reynolds number, for example. This is the flow type. I'm just reconfiguring the interface. Okay. Okay. So I will have a calculate button here. Now let me add a table. Now the table here is unique in a form that it should collect data. So it is not taking direct values, okay? So it's not, for example, taking values from Excel to form a table directly. You are forming the table cell by cell, or let's say row by row. Okay, so this is the challenge. Now I have 4 columns by default. I will take 2 columns. Okay, I will define the first one to be the velocity, meter per second, and I will define the second one to be the pressure loss in kilopascal. Okay. Now let me add another button. Now you can use the same button. However, I would like to add another button that says collect reading. Okay. Now it depends on your design. If you need to press on calculate and collect the reading at the same time. However, sometimes in order, I'm thinking about the graph. Now, sometimes you are changing the same or you are changing the material. So in order to make a proper graph, you should not change the material. This is why I added a button for collect reading. So this means that this graph is for a certain material only. You are changing, or your graph is between P or delta P or pressure loss, let's say, and velocity. So it is not correct to make the graph for different materials at the same time, or the line itself, it will not be correct for different materials. This is why I added a button for collect reading. Okay, so whatever reading I like, I can add it to the table. Okay. So let me now go to the callback of the collect reading push button. This is the push button for the collect reading callback. I need to define the table now. Okay, now where is the table? This is the table name. Okay, now you can give it any name you like. Okay. طيب خليني شوي اشوف كيف عرفته انا هون. اوكي. هون عملت اشي بس شوي لانه I am adding cell by cell. I am adding the table as cell by cell. So let me start. Where's the table? Hi, UI table, push button, callback. Hi. Okay. Now let me define the values of V and dP again. V, dP. Now I will take these values. I will take these values from the edit field. So I will take these values from here and from here. Okay. Let me go and take this one. Where is, yes. This is for V. Okay. And this is for dP. تمام. Now, I will define the table as table أو بلاش. I will define a matrix TA, I will call it, equals to V and dP. Okay. Now, I will define the table as خليني بس معلش أتذكر كيف عرفتها. Yes, this is V and dP. Okay, بس خليني آخذ هاي. So table equals to app dot شو اسم التابل UI table dot value. Okay. اوكي الان عرفنا التيبل اوكي as v and dp. however التيبل عندي الان حياخذ value واحده for v and dp اللي هو حيركب لي or it will only add the first cell. Okay, but I need the table to be continuous. I need to add another reading or another cell. So what I can do is to add this. So once it takes the first cell, it will, okay, it will store the first cell, the first values of v and sorry. Now this means here that you are making a, let's say, array, okay, or now it is a vector actually. For v and dp, it will take the value of v and dp and make the first cell, or make the first row. The first cell is v and the second is dp, and it will put them in the table. I define the table like this. Okay, now the table data will be taken from here. Now because I have another cell I need to fill in, another cell I have to add this again. So each time it's taking the values from the cells. Okay, now if you have, for example, if you can get the results of v and dp as a vector, each one as a vector, you can store them in the table directly. However, since I need to add them row by row, I have to add this one more time. Okay, so every time you press on the button, which is the collect reading button, it will take the values, store them in the table like this. Okay, if you press again, it will take new values and store them in the table. واضح? So let me check what happens now. Okay, so we have these values. Calculate. Tamam. Let's collect the reading. I think we have a problem. 108 table.app.ui table.value. خلينا نشوف where is the problem. Table equals to app.ui table.value. معلش خليني اشوف كيف سويتها. .data, sorry. These are data, not value. Table data, not value. You have to use data. Okay, so let me run now and see what happens. Okay. Can collect a reading, very good. So let me add more flow rate. Calculate, collect reading. Okay, very good. So every time you are adding another value for the table. Okay. So this is the secret here, or this is the major challenge here. App.ui table.data equals to table from TA. Every time you are taking the values of TA and put them in the table, and you are defining the table again. واضح? So we have a table now. Let's go to the design view and make an graph. Graph, we use the axis. So this is our graph. It's called axis. تمام. I'll remove the title. I don't need the title. The X will be velocity. in meter per second. Y will be pressure loss in kilopascal. واضح؟ So now let's define the axis. Let me add another button. I will call it. خليني ارفع هذول شوي. I will call it plot results. أو plot خلاص عشان ما نطول الاسم. Okay. Then I will go to the callbacks of this button. طيب. So I need to make a plot between ايش سوينا هون DP and V. Okay. تمام. طبعا هاي انا خطأان فيها بس ما عليه. طيب شوفوا الآن شو بدنا نسوي كالتالي. أول إشي we need to define the value from the table لأنه the value from the table it will give you many data for V or many values for V. So we define V as TA اللي هو الماتريكس اللي سويناها ولكن ال V عبارة عن إيش؟ عبارة عن الكولوم الأول. So it will be something like this. الكولوم الأول. تمام. والDP will be الكولوم الثاني of TA. طبعا هاي لازم تكون هيك. الكولوم الثاني بإمكاني أكتب 2 وبإمكاني أكتب end زي ما بدك. and بإمكاني أعمل البلوت. اوكي. خليني بس أتأكد. لا والله هاي هيك. معلش تحملوني بس. الجراف هاي أنا دائما عندي جاهزة لما أجي أرسم الجراف. فمش حافظ الكود تبعها. تمام. الآن في شغلة لازم نسويها اللي هي البلوت في العادة بيكون between array and array values and values بarray. اوكي يعني 1 2 3 4. الآن ال V وال DP عندي are vectors. اوكي هو عبارة عن column يعني column matrix but I need to convert it into ايش array matrix row. So I can say that V equals to V transpose and DP equals to DP transpose as well. Now I can plot اليو axis اللي عندي اللي هي شوفوا شو اسم الجراف عندي هاي اسمها app UI axis اسمها. اوكي اسمها UI axis. This is the callback for the it's called UI axis. Okay. So I can say plot app dot UI axis V and DP. قبل ما نعمل رن نشرح الكود مرة ثانية. ال V أخذ لي من الماتريكس هاي اللي جابها هون. اوكي اللي هي ماتريكس هاي حتكون 2 columns بعدد الروز اللي انت you press on collect data بغض النظر. اوكي so you are taking the first column from this matrix اللي هي موجودة في التابل. For DP you are taking the second column or since you have 2 columns only you can use it at 2 or end. Okay. Now, this converts the values of V and DP into array instead of column or instead of vector. And now this is your plot. واضح? So let's press on run. Okay, so you have, for example, 55, 15, and 5. Calculate. I will collect reading now. Then calculate, collect reading. Then calculate, collect reading. Now, we have a problem here in definition of V and DP. طيب. So because we did not define TA. So let me define TA. So TA is to app.UI table.data. اوكي خليني اشيك بس انها صحيحة. Yes. TA equals to app UI table.data. Very good. عم ناخذ الداتا بعدين نفرزها لكولوم 1 كولوم 2. Okay, so I can select any length, calculate, collect data, increase the flow rate a little bit, calculate, collect data, calculate, collect data, then I need to plot. So this is my plot. Pressure loss versus velocity. واضح؟ اوكي. طيب شو ممكن اضيف؟ ممكن مثلا استخدم اللايت. هون في عندي لايت لامب. اوكي ممكن احط لامب هون جنب الفلو تايب. اوكي اللامب هذا شو بده يسوي؟ بدي اشيل هاي كلمة لامب. كلمة لامب بدي اشيلها. اوكي اللامب هذا شو بدي اسوي فيه؟ مثلا إذا كان الفلو عندي if the flow is laminar the lamp will be green. If the flow is turbulent the lamp will be red. Can we do this? Yes, we can do this. Let's go back to the calculate pushback button. We already have if loop for Reynolds number. Okay, so I can add another one and say that if Reynolds شو اسم اللامب؟ شوف let's see what's the اسمه لامب خلاص. So I can write app dot lamp dot color equals to ايش بدي انا؟ إذا كان Reynolds it should be green, so it is G. الآن here I can write as well. It can be red, for example. This is red. Okay, so let's try it now. Okay, so it is turbulent, it turns red. I calculate laminar, it turns green. Okay, so you can add whatever you like. Now, let me add Reynolds number. or بلاش Reynolds number. Let me the pressure loss. Pressure loss. Let me check the maximum pressure loss for oil, for example. It can be 3000. اوكي بلاش البريشر لوس، خليه رينولدز نمبر or velocity افضل. Okay, so I can see that the maximum velocity goes to 6 meters per second. So we can go back to the design view and read the velocity instead of a value, read it in a term of gauge, for example. So I can add a gauge for the velocity. So this will be your velocity in meter per second. Okay, I can make it smaller. So you can read the velocity and using the gauge, for example. You can do it. بس لأنها صارت صغيرة صارت تغلبني بالحركة. Okay. So this is my velocity. So now I can remove this totally. Okay. لا بلاش خليه لأنه عم باخذ منه value على فكرة. We are taking value from here. Leave it as it is. عشان نرسم otherwise we need to go back and يعني fix the code again. Leave it as it is. However, let me take this one and make the minimum value to be 0 and the maximum to be 10, for example. Okay. Then I will go back to the calculate button, callbacks. Okay. Under the velocity, where is the velocity? This is the velocity callback for the edit field. Now I can also add, for example, velocity ms gauge. I can take this and write app dot value equals to v. Okay, so now if you press run, you will have the velocity written in the velocity field and projected in the gauge or velocity gauge. Okay, so the velocity is very small. So let me increase the flow rate. So you can see it is increasing. So this is the velocity. Now you can play with the gauge whatever you like, yani whatever values that are appropriate for your work. Okay. So now it is 6.7. So واضح? You can select the same gauge. You can select any gauge of these, for example. These are results. It projects the results for you. The switch, you treat the switch the same as the push button. Okay. Now knob can be treated the same as the list box. Knob or discrete knob can be treated the same as the list box here and there. So you can select. You just turn the knob into the cast iron, steel or brass. Okay. Slider, we took a list box with radio button are almost the same. Okay. The spinner and the slider are very close to each other, the same. Okay. Now toggle switch والrocker switch والswitch يعني الcoding تبعهم very close to the calculate button, except that the switch is on off, so you have to make it on or make it off. However, calculate button is only push. You push it one time, خلاص, it goes back to its original position. واضح؟ طيب, so I think this is enough. We made a comprehensive example, and I hope it is useful for you. Now, if you have any questions, I can't see. Okay, you can write your question on the chat box or ask to be able to open your microphone and ask me directly. Okay. Yes, Yamita, you can read data from Excel. You can read data, yes, especially in the table. This table, it can be treated as any table in MATLAB. So, however, it has a name of UI table. So, here in the code view, you can take some data table from here. It can be from Excel. You can import it from Excel. Okay, so you can, for example, read an Excel file. Okay. Now, I don't know if I have this application. I did it before. Let me show you how does it work. It can read data from a certain image. I would show maybe the people in the computer engineering or the electrical engineering know what I am talking about. So I have this. Yes, I have this application. Yes. I will show it to you now. Okay, I developed this application during my studies. I needed to calculate the image entropy of a certain picture. So what I can do, I can select the image. If I run, one minute, it will run now. Okay, so it is very simple. However, the programming is very complex because it depends on the image processing of the MATLAB. So you can go and select a certain image, and it was very useful for me actually, because I was studying the complexity of the roads. So let's say this is a certain image. Okay, so okay, there is a problem here. I don't know why, but let's go back to the here. Okay, so you can select any external image, and it will read the image. Based on the image processing techniques, it will calculate something called image entropy, and it gives you an indication of the color mixture of the image. Okay, so this is one type of MATLAB, let's say, app designer tools. In general, you can do whatever you like. You can do whatever program. Now, the next step for MATLAB App Designer is you can make your standalone application, which means that you can have an application. You can call it whatever you like. Okay, I don't know what's sharing now in my screen. Okay. So the coding is the same as MATLAB. Yes, but there is some naming. So if you have seen now, the variables are defined based on the input. It can be slider or table, whatever. Now, once you have this, the app designer, and your file will be .mlapp. You can go and make it as, or you can not, you compile it as exe file. So once you compile it as exe file, you can share it or send it to anybody and he can use the same program without the MATLAB. He should have something called MATLAB runtime only. So he don't need to open MATLAB. It will be something like Word or any other program. Just double click, it will open. It may have some setup files. You can create your own application using the app designer and you can share it. You can make a program. Okay, but the problem here is that the license that we have in the store does not have the compiler. Okay, so you need the full license in order to do that. Okay, so once we go back to the campus, inshallah, I will convert all my applications, inshallah, into standalone applications, and I will share it with the students in the course. Type. If you don't have any questions, خلاص, we finished. I wish you luck, جميعا, and happy weekend. Next week, inshallah, we will have the fuzzy logic using MATLAB. If you are interested in fuzzy logic, you can attend the 5th level of our workshop. It was nice meeting you all today and see you soon, inshallah.